This is Mr. Fakada. We are going to talk about the resistor in series and parallel. And before we start this video, please to have a notification whenever we release some videos. Please don't forget to subscribe and share and like the videos. Thank you. If you like them, just like the videos, subscribe and share, because when you share, you're gonna have a notification whenever we post similar videos. ተመሳሳይ ቪዲዮዎች ፖስት ስናደርግ ኖቲፊኬሽን እንዲደርሳችሁ እባካችሁ ሰብስክራይብ አድርጉ። Let's dive in. So from Ohm's law, you can note that the current I is directly proportional to the voltage, and the voltage is equal to the current I times the resistor. So the resistor is the proportionality constant from Ohm's law, because the resistor is voltage over current. So resistor is not dependent on the voltage and it's not dependent on the current, but it is dependent on the nature of the geometry of the wire or the conductor. So for ohmic materials, materials governing Ohm's law, we have a relationship. So the voltage is here, the resistor is here, the current is here. So the voltage is resistor times current. The current is voltage divided by resistor, and the current is the voltage over resistor. Now we know that the resistance of a resistor is dependent on many factors. So the resistance of a resistor is in the function of length of the wire, the length of the conductor, the cross-sectional area of the conductor, and the temperature and the nature of materials, okay, which is denoted by resistivity gamma. So we know that a resistor of an ohmic material is directly proportional to the length of the wire, and the resistor of the wire is also inversely proportional to the area. So this shows you the resistor of a wire is proportional to length over area. So the proportionality is equal to constant times length over area. So meaning the lengths of the wire, the resistor are related. So resistance of a wire is given by resistivity times length over area for an ohmic material. This is how you define resistance in terms of geometry of the resistance, but the resistance of a wire is as a function of temperature too, but it is given by the resistance under colder temperature times 1 plus the temperature coefficient times the change in temperature. This is how the resistance of ohmic material is changing with what? With temperature. So now for different purposes we use more than one resistor for a specific design, maybe electronic device design or something else. So how do we arrange resistors? So we have two ways of arranging resistors. So you can have the symbol in a circuit. The resistor is represented by this. So this is a symbol for resistor. Then we have usually a circuit. So in a circuit, this is the positive one, this is the shorter one is the negative, and I can have one resistor, okay? If this is one resistor, there is nothing to do. But in many purposes, in many cases, we need to combine resistors for different purposes. If you have only one resistor, it's just gonna be resistor R. There's a potential voltage here, and the shorter one is negative, the longer one is positive always, and the conventional current is flowing here. So there is only one path, a current to flow through the circuit. But for different purposes, we have a different arrangement of resistors like this. Now this is one kind of resistors, okay? So we can have this one is the resistor 1, this is the resistor 2, this is the resistor 3. They are connected in series. If resistors are in series, if there is only one path to a current to flow, all right? So a conventional current is flowing like this. So there is a current 1 here, and there is a current I2 along R2, and you have another current I3 along R3. So this is the current, and the voltage is here, okay? The voltage is here. The point that everybody should note for a series resistor is every resistor is the same, Okay, so this is a total resistor from the source. This is a total resistor. So the total resistor the source gonna give you a total current I total. So we're gonna have I1 here, I2 here, the current 3 there. So for series you have I total is the same as I1, and it is the same as the second current, and this is the same as the third current. Okay, the current is always the same because in each resistor the current into in each resistor is also out of the resistor. Every resistor releases the current that receive. That's why the current is the same in each resistor. And the source voltage, the total voltage, is the sum of what? The voltage drop across R1 V1 plus the voltage drop across V2, R2 V2 plus the voltage drop across V3. Yes, V3 is V3 like this. Okay, now you can derive expression for the total resistor. So what is R total in series? Okay, in series, how do you find R total in series? So you start from this one. Okay, you start from this one. How do you do that? So V total is how much? V1 plus V2 plus V3. Okay, Ohm's law gives you what? The current along, the voltage across the voltage drop, anyone is what? So V1 is equal to I times R1, and V2 is equal to the same I times R2. V3 is equal to the same I times R3, because every single resistor we have the same current here. Every single, because they are in series, there is no current disappear or current is just charge is something conserved. The current into the resistor must be out of the resistor. That's the logic. So this is how you find the V3, and we have the V total is how much? The V total is the I times the R total. Now let's substitute everything in here. So what you gonna get? Instead of V total you are doing I times R total, yes, is equal to, instead of V1 you are doing I times R1, plus instead of V2 you are doing I times R2, plus instead of V3 you are doing I times R3. Yes, so this you can take this I, the three terms common, so I times R total is equal to how much? I into, yes, R1 plus R2 plus R3. So now you have this expression, and now what you do to simplify, divide both sides by the current, so the sum, the total resistor in series is the sum of each one, R1 plus R2 plus R3. This is how you calculate the equivalent resistor in series. Okay, the equivalent resistor in series is like this. Now let's have one example. So you are given a circuit. The circuit is, all resistors, that 4 resistors are given. Each resistors are in parallel, in series, sorry. So R1 is 180, R2 is 1200, and R3 is 900, and R4 is 1 kilowatt, 1000, right? So the voltage, the source voltage is also given. The voltage from the source V is equal to 36 volt. Okay, now you are required to find the total resistance to find the total current. So the total voltage is given. So how do you get the total resistance? So R total in series is equal to the sum of individual resistors. Yeah, R2 plus R3 plus R4. It's because all resistors are in parallel. So this is how much? 180 ohm plus 1200 ohm plus 900 ohm plus how much? R4 is 1000 plus 1000. Yeah, so this is the total. So the sum of these two is how much? 1.8 plus this is 3000. Yeah, 3000 plus 1900. So this is the same as 900. When you add this, 4000. Yeah, 4900 ohm is the total. R total is this much. So you add the resistor in series. Now let's find the current total. So the current total, I total, is V over R total. So this is how much? This is 1000, no, 4900, yeah, 900 ohm. So how much is the total current? The voltage total over the total resistance, and the voltage is 36 volt, but you can say this is 3000 millivolt. Okay, so this, you can make it like this. Then we have 4900 ohm. So the ratio of this, okay, the total current is I total is equal to 0.74 ampere. That is the current. So we have the total current. Let's find, yeah. So the current is 0.74 milliampere. I'm sorry, milliampere. Yeah. Now what is the voltage across R1? The potential drop across R1 is V1. So V1 is how much? I times R1. Yeah, I total times, because I is the same for every resistor R1. So this is I times R1, 0.74 milliampere times 1800. So this is 0.74 times milliampere times 180 ohm. So the voltage across the V1 is approximately 1.33 volts, or 1332 millivolts. This is like this. So find the voltage across V2. That is, V2 is equal to how much? I times R2. So I is the same for everyone. So this is 0.74 times, how much is R2? 1200 volt. Okay, 1.8 kilovolt means, so I mean kilo ohm means, so 1.2 kilo ohm means 1200 ohm. So this is equal to how much? So this give you 888 millivolt, which is 0.88, or you can call it 0.89. okay, 0.89 volt is there. So V3 is equal to I times R3. Okay, this is equal to how much? So R3 is 900. This is 900 times how much? 900 times, and so R3 is 900. The current is 0. Yeah, the current is 0.74 milliampere. This product is equal to 666, it says. So this is the same as, this is millivolt here. So divided by 1000, this is approximately is equal to 0. Okay, divided by 1000, 0.67. Yeah, 0.6 or 0.7, 0.67 volt. Okay, this is 0.67 volt. The last one, but is not this one, is how much? So V4 is equal to I times R4, resistor 4. So resistor 4 is 1 kilo ohm. This is equal to I is 0.74 times the resistor is 1 kilo ohm times this is 1 kilo, 1000 ohm. So this is gonna give you 0.74. okay, because this is milliampere. So 0.74 times, 0.74 times. So this is how much it is, 0.74 volt. Okay, so that is the current. All right, the voltage across R4. So this is 0.74. I'm sorry, 0.74 volts. Now this is how you find each resistor. Let's go to the other part. For parallel combination of resistors, you connect resistors in parallel. In the case where you have many resistors, like this, maybe one resistor, this may be resistor 1, you can have another resistor 2, you can have the third one, maybe resistor 3. yeah, so these are what the resistors. So in case of parallel, I'm talking about parallel combination of resistor. Now in this case, what you do is you have this may be positive terminal of the resistor itself, this may be negative, then the same terminals are connected together, this is also connected together. Yeah, so this is why, that's why this the same potential are connected together. So these all are at equipotential, these all are also at equipotential, then the combination of these all is connected with the source. Now the thing that you have to note in parallel combination is, so you have three resistors in parallel, the voltage across the first resistor is equal to the voltage drop on the second is equal to the voltage drop on the third, and the current from the source, the conventional current, may be flowing like this. So here is the total current, here the total current in here branch out. Yeah, the current branch out like this. This is another one part, this is the other part, this is the other part, but this is the total I. So this is I1, okay, this is I2, and this is I3. So you can see this in is equal to the current into a joint is equal to the current out of the joint, you may say like that. So this means simply I total in parallel is I1 plus I2 plus I3. So you do the current the same, the same, yeah, you add the current. Now how do you find the equivalent resistor? So this is the voltage from the source, the total voltage. So the other thing that everybody should note is the voltage from the source is equal to the voltage across, yeah, we have already mentioned that part, is equal to the V2 is equal to the V3, because the same terminal of the voltage are connected together, positive together, and the positive ends of these resistors are combined together and come to the positive end of the battery, and the other negative connected together, and the combination of the negative branches are connected and connected with the negative end of the source. So what we know is the voltage, the current total is the sum, yeah, I1 plus I2 plus I3, yes. But what do we know? I1 is the voltage over R1, and the voltage 1 and the voltage 2, the voltage 3 are the same. So I2 is the same thing is true for I2, the voltage over R2, and I3 is the voltage over R3. So you insert, and I total is the voltage over R total is equal to the voltage over R1 plus the voltage over R2 plus the voltage over R3. Now you can have this voltage common, and you're gonna have this is the V times 1 over R total is equal to the V into 1 over R1 plus 1 over R2 plus 1 over R3. All right, now divide both sides by V, we're gonna get cancel this one. So in parallel combination resistors, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. That is how you calculate resistors in parallel. Let's have an example. All right, now we are given 3 resistors called R1 is 15 ohm, R2 is how much? R2 is 10 ohm, yeah, R2 is 10 ohm, R3 is how much? This is 15 ohm, 6 ohm, yeah, this is 6 ohm. Now we are required to find the R total 1, the current across the total, the current total is how much? The second is the current 1, current 2, current 3, because we know the voltage is the same for every single source, branch. So how do we get R total? 1 over R1 is equal to how much? 1 over R1, R total R1 plus 1 over R2 plus 1 over R3. Yeah, this is the reciprocal sum. So this is how much? 1 over R total is equal to 1 over R1 is how much? Is R1 15 plus 1 over 10 plus 1 over 6. Okay, so this is 1 over R total. So 1 over R total is this much. So you can take 30 as a common LCM. 13 divided by 15 is 2. 2 times 1 is just you put 2 here. Then this is 30 divided by 10 is 1. 1 times 13, 3 times 1 plus 3. So this is 5 plus 5, because 30 divided by 6 is 5. So this give you how much? 4. Yeah, this is how much? 3 plus this is 5 plus, yeah, that's 10. That's 10. Now we have 1 over r total. 1 over r total is how much? 10 over 13. Oh, this is equal to how much? This implies r total, you have to switch, yeah, you have to reciprocate. So 1 is equal to 30 over 10, yeah. So the r total is equal to 3, yeah. You can use your own technique to add this r1, r2 and r3. So the total resistor is 3. R total is equal to 3. That's very important. Now let's find the current total. Yes, the current total, I total, is equal to how much? The V over the resistor total. This is equal to the V is how much? It is 12 volt over 3 ohm is the total. So that is 4 ampere. The total current is 4 ampere. Then this 4 ampere, I total is 4 ampere. I total 4 ampere is distributed to the circuit. Now we are looking for the current through I1. The current through resistor 1 is equal to how much? V over R1. I'm using the same V, yeah, because V is the same for every single resistor because they are in parallel. Now this is equal to how much? V is how much? V is 12 from the source over R1 is 15. Yes, the 15. R1 is 15. So this is 4 over by 3. 4 by 3 by 3, 5. You can multiply this by 2 over 2. That is 8 over 10. So the current through the first resistor I1 is 0.8 ampere. All right, now what is this? This is the second thing. I2 is equal to the same V over R2, but V is how much? 12 over R2 is how much? R2 is 10 volt, 10 ohm. So this is 1.2 ampere. You can see as the resistor decrease from 15 to 10, the current is increasing. Now how much is the surge current? I3 is equal to V over R3. Yeah, so V over R3 is how much? 12 over R3 is how much? R3 is given to be 6, so this is gonna be 2 ampere. All right, so you can check that whether I1 I total is equal to I1 plus I2 plus I3. This is we know this is 4, yeah, 4 ampere. Yeah, so what is this one? 0.8 plus what is this one? 1.2 plus that is 2. So 0.8 plus 1.2 is 2. 2 plus 2 is 4 ampere. This is how you do the resistors in parallel. Sometimes you can have resistors in both parallel and series combination. So in this specific resistor, you are required to calculate, find out the R total. You are required to find I total. You are required to find I1, I across one of the resistors. Let us give a name for each one. This is 1, this is, let's say this is 2, and this is 3. Now we have 3 resistors connected, but the resistor 3 and resistor 2 are connected in parallel. So we need to find the sum of the two in parallel, and we need to write equivalent circuit for the two. So for 2 resistors in parallel, how much is R total? R total is R1 times R2 over R1 plus R2. Yeah, this is how you find for 2 resistors in parallel. R2, this is how much? So 8 times 12 over 8 plus 12. Yeah, so the total resistor, the 2, I don't have to say total, but it's better to say R2 and 3. So this is 2 and 3, yeah, R2 and 3. So this is how much? You can say this is 8 times what? 8 times 12 over 20. Yeah, the sum is 20, but you can say 20 is 4 times 5. 4 times 5. Yeah, you can make it 4 times 5. So this is how much? By 4 you can cancel, by 4 2, by 4 1. 2 times 20, 2 times 12 is 24 over 5. Now this is 24 over 5 multiply by 2 over 2, 48 over 10. So R23 give you what? 4.8 ohm. Now whenever you do this one, so R23 is how much? 4.8. Okay, after you did R12, the combination is 2 3. I mean, so 8 and 12 are in parallel, and we did the in parallel, and their result is 4.8 ohm. Yeah, so we do this. After we do this, so these two resistors are acting as one single resistor like this. So R23 is 4.8, and R1 is here. So R1 is here. R1 is 7.2. So how much is the total resistor? So in these R12, I mean R1 and R23 are in parallel. So R total is equal to R23. All right, R23 plus what? R1. So this is equal to 4.8 plus 7.2. All right, so that is 5, like 5 plus 7. So the total resistance is 12 ohm is R total. All right, now we have the total resistance is 12 ohm. Now what's the next thing? The next thing is to get I total. I total is how much? I total is the voltage from the source divided by the current, the resistor total. This is equal to 6 volt over 12 ohm. This is gonna give you 0.5 ampere. The total current is 0.5 ampere. All right, that's very. The other thing we are required to do is to find I1, I2, R2. All right, it can be you maybe find the resistor across the voltage across R1 may be required. So how do I get I1? So the current through this one is I1, and the current this one is I23. Yeah, so I1 is equal to I total is equal to I23. You need to know this. Why? In this current circuit, this the total is 0.5 from here, ampere from here. So these things are in series. So the in series current is the same. So I1 is 0.5. The combination is also this one has 0.5. So I1 is equal to I total is equal to everything is 0.5. All right, except those things in parallel. Okay, except those things in parallel 0.5 ampere. All right, now how do you get there is no, okay, how do you get the, we have I1, we have, so how do you get I2 and I3? So you can see here I2 is resistor 2 is 12 ohm, and resistor 2 and resistor 3 are in parallel, and they each have what? Each have a current. So the parallel things, this one R2, R3 are in parallel, and their combination has a total resistor of this match. Yes, how much is the voltage across this combination? You do V23 is equal to I times R23. Yeah, R23, because this V23 and this one R2 and R3 have voltage in common because they are in parallel. So this is equal to how much? 0.5 times 4.8. So this is gonna give you half of 4.8. So this give you how much? The voltage across the two resistors, the parallel combination is 2.4 volt. Okay, 2.4 volt. So what is the current through R2, the 12 ohm resistor, the 12 ohm? So this is the voltage that's shared from this, the combination, the V23 divided by the 12 ohm. Yeah, so this give you 2.4 divided by 12. How much is this gonna be? That is 0.2. This is 0.2 what? 0.2 ampere. This is the voltage across, the current across R12. How much is the current out the 8 ohm resistor? The 8 ohm, it is the V over how much? The V over the R12, the 8 ohm itself. So the V is how much? The V across here, across there are the same. So that is the V23 is how much? It is 2.4 divided by 8 gonna give you, I think this is 0.3. Yeah, 0.3. Now this is for the parallel. What else? Now what is the current through? Yeah, we have already done the current. The voltage one, the voltage across the 7.2 resistor. Yeah, so this is the current. You can say the current total, or the current through R1 times what? Times the resistor itself. So that is 7.2 times 0.5, meaning half of that. This is equal to half of 7.2 is how much? It's gonna be 3.6 volt. That is how you solve problems involving parallel series circuit. Drawing equivalent circuit like this is very helpful. Thank you for watching this video. This is Mr. Fakada. Guys, please like and subscribe and share the video if you like it, if you find it is helpful. So I will get you with other videos in some another time. Thank you for watching.